Welcome everyone to this workshop. Actually, this is, I think, the workshop with the most number of participants in this semester. Pretty nice to have you all there and a lot of new faces that are not common LODAC faces. Just before getting started, this is a beginner-only workshop, as we also said in the email and the Luma page and everywhere. So for those of you who already use LLMs and have used APIs, it might be repetitive. Sorry for that. We have to usually cater to every background. Unfortunately, we usually, the best background to cater to is usually the beginner, because if you do only advanced, then some people can't understand what's going on. So we do from beginner level. This is like from total beginner in LLMs. If it is repetitive for you, sorry, but you will anyways have free pizza in the end. So you can just save your work and then have the free pizza. No one said that. So what's the whole thing about LLMs? LLMs like ChatGPT are the things that you might say, okay, we ask questions and they answer, but ultimately they are text generation engines. They basically, from a certain set of inputs, which can be your images, your text, or whatever, they generate a bunch of text. That's it, right? They can be used for summarization, for translation, for doing chatbots like ChatGPT. The whole way how they work is they just predict the next token based on the prior token. By token here, we mean word. We can refine that later on. But that's how the LLMs work. Like, for example, here, imagine the LLM is producing this response for me. Natural language processing, NLP, and then it wants to produce the next word. The whole model basically takes everything until that point as an input and predicts the next word as the output. For example, it takes natural language processing, NLP, and then it predicts as output the word is. Then the next time it will predict the output and. You might say, how does it work? Of course, it predicts the word that has a high probability to be there. And this will allow these models to be able to answer to our questions. Because usually when you want to form sentences, also as a human, after each word, you say the word that is most likely to come after. Right? So basically, it's like one at a time generation. That's how normal LLM works. And of course, they train these models on a lot of text in the web, collected from different sources, on and on, to be able to provide support into how it can best answer our questions. So answering our question is basically just completing the text word by word. Might seem unintuitive, but that's how it works. We had a long history until we got here. We had this GPT. Okay, I didn't even include GPT-1 because I couldn't find the web interface that I could easily use it. I asked the question from GPT-2 completely. I like attending the boot camp, but then see the rest. I didn't want to go to the summer camp. I want to go to the summer camp because I want to learn how to do it. If now GPT talks like this, you will think that something is wrong with OpenAI, right? But that was how all started. And it's we saw that it improves more. As you see, the number of parameters. Okay, we don't go to the details, but the number of parameters is basically measured how big these models are. GPT-3 like bumped the number of parameters up, and as you can see, okay, the answer is a bit better, but you also see some nonsense in the output. Of course, it improved more in GPT-4, and just recently improved even more with GPT-5. Not a surprise, right? And this is only OpenAI, but also other companies have been involved in this space. Even research labs, we have language models that are developed in Switzerland. We have the Apertus language model that we'll talk about later, and so on. So yeah, large language models are getting bigger. There are certainly downsides of these models. These models are not really humans, so they are just models that will predict the next word. Of course, this will lead to a lot of problems. If in their data that they were trained on, they see a single word a lot, they will just use that word a lot. This was this study that checked the number of times people use the word delve in papers. And they found that basically after ChatGPT was released, the count was like super high. It's because everyone was writing their papers and their reports with ChatGPT, of course. Who doesn't use ChatGPT for writing reports? And because it tends to use certain words more and more, you see that they were used here more, right? That means these models are not really models that will answer real questions, but just trying to predict the next word. But we are giving, for context, we are giving a bunch of explanation, and then we will get to the practice part. So basically, how they work, again, is that at each step, they find the probability of each token or word in the whole set of words that can come next. For example, we say the weather in summer is, then from all the words in the dictionary, what are the most probable words to come? Hot, warm, of course, they are the more probable words. And then some words like cold, of course, have low probability, right? If someone said the weather is summer is cold, you might think that they're a weird person, right? Or they're drunk or something. So basically, hot has the most probability here. And that's how the LLMs work, because they return the word at a high probability. And by this way, they can learn to answer your questions in a correct way. But should we always pick the most probable word? That's not also true, because the model can turn out to be repetitive. So we use certain strategies to in LLMs to make sure they are not models that just repeat the same sentence again and again. Because as you saw in GPT-2, it had the tendency to repeat some stuff, as you can see, because of course, I wanted to go to after that summer had a high probability, but this is not what we want. We want to also have a bit of diversity in the answer so that it's like more flexible on and all. And to do that, we can play with the parameters. For example, we can say, I only want words that are higher than a probability, and based on those, we select the word according to the probability. What does that mean? Imagine I say, I want everything more than 0.2, and then based on those, with the probability 3 over 3 plus 6, I choose warm. With the probability 6 over 3 plus 6, I choose hot. So I choose, is that clear? Fine. So basically, I choose among the top set of words, instead of just choosing the top word, right? So this is something that we can do in LLMs. You will also see in practice. Another thing that we can do is a parameter called temperature, which people in the LLM world talk a lot about. And again, you will see in the code. By temperature is basically a measure that the higher it is, the more undeterministic the selection would be. Temperature 0 will always return you the top word. So here, if we say temperature 0, it will tell me the weather in summer is hot every time I use the LLM. If the temperature is higher, the probability of choosing the words on the list would be higher. And then if your temperature is like very, very high, it might even say the weather in summer is cold. And that might lead to bad consequences. So we should always play with the temperature. We usually say temperature of 0 for factual responses, because we only want the top token to be generated. And temperature of like 0.5, 0.6 for a bit more creativity in responses than temperature of 0. Was that clear? So basically, just we don't go into the technical.
Can you explain that again about the temperature part? I didn't get it. Like for 0 temperature, the higher probability. Yeah.
So basically, the more temperature it is, the distribution is more diverse in the list of words. Temperature 0 means only take the top word. I mean, in practice, it's like some. So we aim to. So basically, as I said, there are different words with different probabilities that come, and temperature parameter allows us to find which word should return here. If the temperature is 0, we only return the word with the highest probability on the top. And if the higher the temperature is, there is a higher probability of choosing other words down the list. And basically, the maximum temperature makes it a uniform distribution so that every word in the world can occur with the same probability, right? So, I mean, I won't get into the mathematical details, but there is a kind of function that the temperature is a parameter of the function, so on and so forth. And of course, what else you can change in the LLMs is to set the maximum number of words that it can return, all of that. But okay, these might all seem a bit too much. Let's see in the practice, I think, right? Let's play with a wonderful tool called the OpenAI Playground that allows you to play with these parameters and see how do they practically work. So here, okay, first of all, I have to explain, this is something that you can only use if you have billing enabled in your OpenAI account. So if you go to this link and you have not added your credit card to your account, you can't use it. Sad, sorry, but for the rest of the workshop, we will, by the way, distribute API keys for you to use. But for this, you have to add the billing. But you can at least see how it works. I go to platform.openai.com and just create a prompt. So there are a bunch of things I can do here. Fail to load subscription. Oh my God. Let's see. Let's try again. Okay, now work this time. Here you can choose the LLM that you want to use. Of course, OpenAI provides a lot of LLMs. For example, by default, it was chosen 4.1. This is one of the LLMs of OpenAI. I will just keep it. Here, there is a parameter that here is a button that you can adjust the parameters, as I said. Let's try. Temperature of 0. I will write, for example, here, what is the for example, how do LLMs work? Okay, here's a question that I ask, and the temperature is 0. So now, as you can see, generating words one by one, because as I said, at each time it gives you the word that has the maximum probability to occur, and it's working because the first word is large, and then the most probable word after large is language. The most probable word after large and language is models, and so on, right? Maybe keep this in your mind. Large language models like GPT-4. If I ask the same question again, it should give me the exact same answer, right? Because the temperature is 0, and each time temperature 0 just returns the top occurring word. Yes, as you can see, it's the same output, right? I hope. I mean, I think it was the same output. Ideally, it should have been. So, but what if I increase the temperature? If I increase the temperature, for example, again, the same question. Why this not working properly? I increase the temperature, for example, to 1. Okay, for some reason, it's not working. It's too weird. Refresh again. Sometimes the platform is a bit buggy. How do LLMs work? And the temperature here is 1, right? So this time it should be a bit different. I mean, the beginning is the same, but here I think it was written different. Not work by predicting, but it changed a bit. I hope. Ideally, it should have changed it. So maybe we can try again. You know, it does training architecture. So next time, if we try it again, it should be a bit different. Yes, it started with architecture, as you saw, right? So because the temperature is higher, it's not only giving the maximum probability word, but it's choosing from a set of words. But if I increase the temperature too much high, it will just give me gibberish results. Gibberish, how do you call it? But it will give you results that are not very valid. Let's try it. I will increase the temperature to like maximum, to that maximum in OpenAI playground 2, and I ask how do LLMs work. And you can see that it literally is generating stuff that does not make any sense. And the reason is because though the temperature is so high that it's just using the words on the very bottom of the list, and those words do not have any meaning, and are not because they were very low probability. But because the temperature is so high, it's just returning some stuff. API like some bio context, rapid or micro, whatever. Who cares? But that's how these models work. So we should know that okay, they are not humans. They are just returning the high probability. Yes.
What corresponds to tokens in the current LLM?
I will give a briefing on that. Yes, that's I think in the next slide actually. Yeah, I will very briefly talk about it. So, what's the difference between token and word and all of that I was saying? Each sentence in our language contains several words, and each token is a meaningful unit of characters in our definition. For example, I think in the summer bootcamp, this is like an example. It's a slide from our summer bootcamp. I didn't change it actually, sorry. But one idea of tokenizing is each word a token. I am attending, so on, right? So token is a word that can't be split into halves. However, we can still make it a smaller units. One idea is like this. So we had this, right? But you can see that there are a lot of words that are contain multiple parts. And maybe it's a good idea to tokenize them into their parts. For example, instead of having check-in as the word, we have check as a token and in as a token. LLMs should find a good balance between this, and they have their own tokenizers. Usually each LLM has their own tokenizer. The idea of tokenizer is to find a way on how to tokenize a sentence or a text into unit of words that make sense. It has importance because, for example, attend and attending are two different words, but their meanings are very similar. So if we split attend into attend plus ing, it's easier for the LLM because it knows, okay, I have to use the verb attend, and then I have to add ing because that makes sense in the English syntax. So there are a lot of ways of how these two tokenizing. We don't go in depth. I mean, ready to answer questions on this after the presentation and after the workshop. But that's in a nutshell, we can split sentence in different ways. That's what always there's not the case that one word is one token. One word can be more than one token, as in this example. Is that fine? I know I'm going too fast because we have a lot of content. But anyone have questions? All fine? Yes.
So they also learn the tokenization, or
well, depends. They learn usually the embedding from the tokenization, but I think mostly they just have the rules on how to tokenize things. It's not that they're also innovating the system. Like they're not weights of the model to be trained. If you're coming from deep learning background, they're not weights of the model. Like that's one step before. But embeddings are different. Like, but we are not getting into that in this workshop. All fine? Everyone got this? Good then. I hope. So I said all of this to say that LLMs have different behaviors, and these behaviors allow us to use them in our apps and systems to make our apps better. Because when LLMs were trained to just generate the next word, next token at a time, they had some interesting behaviors that came out of it. Otherwise, ChatGPT wouldn't have been born, right? So, for example, they were able to answer questions without giving anything. You just ask the question, the capital of Italy is, and it will just answer to you. Like you just, okay, of course the rest is a bit weird, but you just take the next token and it's the answer. Even GPT-2, which is pretty old, did it. And of course, GPT-4 and GPT-5, as you already know, can answer questions properly. We call this zero shot. By zero shot, we mean we are not giving a hint or example to the model on how to answer questions. We are just giving the question and expect it to answer. And actually, they're good. Like LLMs are pretty good in zero shot. You just ask them, I'm assuming in your course that you have done a lot of this. You just give them a question and they will just give you the answer. Just zero shot behavior, and the LLMs are pretty good at this. Again, we call it zero shot because there is no zero example training examples. Zero examples in the prompt. And of course, in cases that it might be difficult for the model, few shot prompting is a good idea. By few shot, we mean that you give some examples, and then based on those examples, the model learns how to answer. You might think, I have not ever used this in asking ChatGPT. Yeah, true. But if you are using GPT in your app, you want it, for example, to return information in a certain way to the user of your application. And it's better to give those certain formats in the prompt as examples so that the LLM can know it should return information in this format. It's actually pretty useful for the LLM to know this. And even, again, all the models like GPT-2 can automatically understand that, okay, they should write in this format with the arrow. Germany, Berlin, France, Paris. Of course, GPT-2 was weak. As you saw, it found that the capital of Switzerland is Zurich for some reason. I don't think GPT-3 and 4 have this problem. I mean, there is a reason actually behind why it returns Zurich for Switzerland, but that's we won't get into it. I can talk later about it. So few shot is good when you want to enforce your LLM to return the information in a certain format that you want. You give examples, and the LLM will listen to that examples and give information in a similar pattern. Of course, quality of the answers can differ a lot, especially more difficult questions. And that's why we have to do prompt engineering, which means asking questions in a way that the LLM can understand it better. There is another thing, by the way, getting almost near the end of this part of the presentation, then we'll get to the code, sorry. But another behavior that we found from LLMs is what we call the chain of thought. What does that mean? They asked an early LLM a question. The cafeteria had 23 apples. If they use 20 to make lunch and bought 6 more, how many apples do they have? The answer is 9, but the answer is 27. You might say why? And it's expected, right? Because these LLMs do not have calculators. Normally, they really output the most probable next word. And here, the most probable next word, for whatever reason, in the list was 27. I mean, it was no calculation happened. It was just there. So this is wrong. But then they found that if we ask the model to think first, it will think. And here, actually, the model can get it correct. Because you can see, for example, it writes 23 minus 20. And then the most probable word to come after this is the word 3. The most probable token is the token 3. Because everyone in the web that wrote 23 minus 20, after that, they wrote 3. So they found that if you ask the model to think, and then they give the answer, they give it in a better. Where should you use it? If you want in your app, or if your model is doing something, like it's deciding on something. If you are having a chatbot that thinks, if the user has done this or that, I will do that. If the user has asked me to do this, it's better to ask the model to first think and then decide what to return to the user. Because the thinking results in much higher accuracy. Is that clear? So ask model to think step by step, right? You might have seen that models, actually GPT-5 currently does it automatically sometimes, it tells you thinking longer for a better answer. I'm assuming most of you have seen it. But previously they didn't. And if you use the API directly, you should be careful about all of this. And of course, reasoning models are better. Sorry, reasoning. And then reasoning models came here. Reasoning models are basically models that have this internal thought process internal in them, and basically they automatically think before they answer. They are trained to automatically produce a chain of thought before answering, similar to how we as humans think for a long time before responding to a question. Also, these models have the ability to recognize and correct their mistakes, to break down steps, to try different approaches, blah, blah, blah. But they also do a lot of overthinking. So if you use one of these thinking models, let's ask them, hello, how are you? And then you see their thinking process, you will see the user has asked me to say hello. I need to be polite. I need to be blah, blah. Like it thinks like overthinks everything. So reasoning models are good for some things, and normal models are good for other things. And better to have all of them in your toolbox so that you can use them whenever you want. And of course, reasoning models such as O1 has a much higher accuracy than other models such as GPT-4o and so on, as you can see here. And last thing before I hand over to Parham is the concept of retrieval augmented generation. What's this? So LLM do not know your own stuff. If you ask an LLM about the question, it just knows it from the word knowledge it has. But imagine you want to have a chatbot that will support the users in the prices of your products that you are selling in your website. Of course, the LLM GPT does not know about your products. Imagine you are selling cars, you are a new company, and how GPT should know the prices of your cars? The idea is that we have a set of documents or files that are personal to us, and basically the language model will find the relevant part of your website or your personal documents to be able to return a response that is both high quality, like LLM quality, LLM or not high quality, but LLM quality, and also grounded in your real documents. For example, I said about the company, but for example, another option is legal support. Previously, if you ask a GPT, like I want to like have a legal support, how to found a startup, or how to solve a legal dispute or something, they could have said things that are not right. But if you put all of the legal documents, all of the rules, and all of the constitution or whatever of, for example, a nation into the LLM, as terms of this process, it knows that it should give the answer based on those stuff. So it will not invent new answers, or as we say, hallucinate itself, but rather just pays attention to the documents that you pass to it. Another use case are educational tutors. For example, you want to build a chatbot to help students, for example, learn how to learn, for example, a certain part of history, and you want it to ask questions from your textbook that you are teaching in a school, not general questions. So you pass the content of the textbook as documents to the model, and it knows how to access those documents. I mean, you already have surely tried this in ChatGPT, but if you are, like you will learn today, want to integrate these LLMs into your real websites, you need to know that you should use all of these tricks that we will see examples today in order to make it work. So with that said, maybe, yes, with that said, maybe you can come. Should I connect yours? Imagine there is a big function. For example, x times 2 plus y times 3 or whatever, right? Very big function that gets the input your text and then outputs the probabilities. These are and this function is found by looking at all the data you can collect from the internet. So you can collect all the data from the internet. You can find a function that returns the probabilities according to that text. Because, for example, if on the internet I see capital of France is Paris, ideally that function should return Paris as the most probable word after capital of France is. You do this function, you train it on all of the data in the internet, and you update the function over and over with very big GPUs and all of that NVIDIA GPUs or whatever. You update this function over and over until it gives you Paris as the most probable word. And then if you do this, then the function will also work on new text and will give us words that are high probability. It was a very brief and non-technical explanation, but also can also talk more about it. I hope it was clear enough. I know it's not very easy to say it briefly because LLMs are a bit complex. Even researchers don't know really how LLMs work. But yeah, fine. Good. Perfect. So then
yeah, thank
I'll
you,
hand over
Parsa.
and then
Thank you, Parsa, for the technical part. Hello, everyone. My name is Parham. In this part of the workshop, we are going to go over some practical tools, and we are going to review some API services that you can use and integrate in your projects to actually use these LLMs. And we are going to start with Hugging Face. Hugging Face is one of the most widely known platforms for sharing and downloading some of these open source LLM models and their data sets. And you can use the library in Python called transformers, or you can use the Hugging Face API to access these models. Let's go to the website. So if you open their website, this is probably something you see. I mean, I have an account here, so maybe you see something different. But if you go to the models tab here, you can see a list of all the LLM and natural language processing models. You see there are about 2 million models. That's quite a lot. These models are not only for text generation or for chat instruction-based models. These models are for different types of tasks. You can filter models based on the task that you're interested in for your application. From this left-hand side menu here, you can, like, for example, select to see only text generation models. Oh, sorry. And also you can get to choose the number of parameters you're interested for your model to have. This is an important part because based on your application, you want to select a model with appropriate number of parameters. Because the higher number of parameters your model has, the more storage you need to locally host the model, and probably it's going to take much more computational resources for you to use this model on your own device. Imagine you're developing like a mobile app, and then you use like a really large, complex, large language model as a feature for like a chatbot there. Sometimes it doesn't make sense, especially considering the fact that nowadays robust chat-based models, they have about 3 to 4 billion parameters, and which translates to about 12 gigabytes of storage. So it doesn't make sense to store and host some of these models on your device. And that's why we also introduce API services later on. But just to cut the discussion in short, you can filter the number of parameters from this part. And let's see an example of these models here. I'm going to select, for example, GPT-2, like a basic model from OpenAI. After you select a model from here, you can get to see some description about the model, like what was it trained on. Here it says, for example, it was trained on English language, and you can see some descriptions about the model's architecture. You usually see a snippet of code on how you can use this in your Python code. And again, just to remind, there is a library in Python called transformers that you can use to basically load this model and host this model. We are going to go over some notebook examples later on, but just for the purpose of explaining the website, I think this does the work. And also, like, you have like a community space here that you see people have asked some questions. You can think of it as like a GitHub, but for LLM models. And this is actually a really nice place to explore and try to select the model that you are actually looking for your application. Yeah. And also you can see the number of parameters this model has. So in this case, it has about only 100 million parameters. It's just such a lightweight model. And yeah, so before we go to the coding examples.
And yeah, 100 million each lightspace.
Yeah, it's lightweight because nowadays robust chat-based models, they have about 3 to 4 billion number of parameters.
More, like 3
more,
billion
yeah.
considered big. So
yeah, that's right. There's also like a platform called Hugging Chats. I just figured it out today, and it's just like ChatGPT. You can go there and just like ask it anything. And the good thing about this is that you can select the models from here. You have about 120 choices of models, and these models are all available because of a service that Hugging Face provides called inference providers. Inference providers are some set of AI cloud-based companies that allow you to actually send some HTTP requests instead of hosting these models onto your own device. So you can just send some API requests to some of the endpoints and just get the response back. We're going to see some examples in the code, but basically you can just select models from here. And let me show you an example of one of the models that is supported by inference providers. It's GPT open source model. As I said, some of the models on Hugging Face, they are supported by something called inference providers. This is a service that Hugging Face allows you to interact with these models without needing you to load these models onto your own device and by just sending some requests. Here you can get to just test it out. You can send something, define an LLM, for example, and what happens in the backend is that this sends some requests to like a provider. In this case, it's Grok, and the computation all happens on some server on some backend. You can also get to use this in the code. If you click on View Code Snippets, you can see how you can use this in code. So previously, there was this transformers library that we just saw here. Let me just scroll down. We just saw here an example of it, that you can import pipeline from transformers, and then you can define the model ID and the task you're interested in. And this way, the model is loaded onto your own device and hosted on your own device, and the output is generated. And here is another way that you can basically generate outputs for the models that are indeed supported by these inference providers by importing another library called Hugging Face Hub, and just providing your API key here and defining the model and giving your input. Regarding the API keys, for using this service, you need to create an API key on your profile. And for doing that, if you create an account on Hugging Face website, and if you go to your profile, and here again is an example of how you can use this transformers library and use a method called pipeline to load the models from Hugging Face environment onto your device, and give it like a simple message input and ask it, for example, who are you? This is just like an example. Okay, so for this part of the workshop, we are going to work on like a notebook. So I think it would be the right time to ask you all to clone the repository that the link is on here if you want to follow along. It's like a GitHub repository. So if you have a laptop, perhaps you can code along if you want. And also you have some time to create a Hugging Face token if you want, because you might need it if you want to change the models. And also feel free to ask any questions. So we're gonna have like about 5 minutes break just to make sure everyone is on the track. By the way, if you want to store your Hugging Face token somewhere, you can put it here in the .env file. Just replace your Hugging Face token in case you generated any. It's not necessary if you use some basic models like GPT-2. You can of course test the notebook with some basic models, but if you want to change the models, then that's when you want to use your token. So if you have generated any Hugging Face tokens, you want to put it here, and then we can start from there.
Sorry. So first step was to clone the repository. That is already done, and the next step you're telling, right? Or you already told something offline, because I was not following. Thank you.
We are going to now continue with Hugging Face. You want to first run this cell that loads the token that you provided in .env. I have my secret token stored in another file that you indeed don't see. So, and when you run the second cell, it should print out the first 10 letters of your token just for the verification that everything is connected. You should be able to see the first 10 letters of your Hugging Face token here. OpenAI is the next topic, but yeah. Okay, so we are going to first install some libraries that we'll need, transformers and torch.
This will take some space on your device. Just
It will take some space, it takes some time, but I already have them installed and it just takes like 0.6 seconds for me. So don't worry if it takes some time for you. And let's first start with the pipeline method we saw in the examples. We can do different types of tasks. You can define a model using the pipeline method. If you remember, you define the task you're interested in and you just give it the model name. I'm going to go with GPT-2 because it's like the basic model. It's lightweight and you can just see the
GPT-2 in reality.
Yeah,
just for...
we're going to change it to a more like robust one. But let's go with once upon a time there was a, and let's see what the generation will look like. So it's important to know that GPT-2 is a text generation model. So it tries to complete your sentence. And when you run this cell, it tries to load the GPT-2 weights from Hugging Face. So the first time you run it, it takes some time. You probably see some progress bar that it tries to load the model. But after the first time, this is cached and then you see the response immediately. And you can see here that the generated text is once upon a time, there was a man who had made a deal with the king. He wanted to be the king of the world's kings. And I mean, it doesn't make sense, right? Because we used GPT-2. Let's go with a more...
GPT-2 was trained on a lot of the stories.
Oh, that's the reason. Okay.
I think GPT-1 and I think GPT-2 also.
Let's just select text generation and just filter out to consider lightweight models. And then let's just maybe go with, where was the model I was interested in? Let's go with maybe, it was Meta Llama, but not, it was not Instruct. Okay, let me just search it up. Yeah, let's go with this model. It's a 1 billion number of parameters model. And you can simply just copy its ID and just come back to the cell and change the model here to now Llama 3.2, which is 1 billion, which has 1 billion number of parameters. And then I expect it to take a little bit much longer time because, of course, it's a 1 billion parameter model.
For people who don't have GPUs on their laptops, this might take much longer.
Yeah, because on Mac it's using NPS.
Yeah.
And now the generated text, it's a bit more meaningful. There was a small company called Microsoft. I mean, I don't know about that, but once was it? Okay.
Yeah.
It was a software company and its founder was the guy. Okay. So you can change the models and you can define the task. This is one way of doing it by using this pipeline, but I want to also emphasize on another way I'm doing this, and this is using the tokenizer. So you remember Parsha already explained about tokenizers and the fact that these LLMs use these tokenizers to tokenize the input to some set of IDs, and then these IDs will be generated. You can also implement this by actually using the tokenizer. And for that, we are going to use this generic class called auto tokenizer from transformers. You can load a tokenizer of a model by using auto tokenizer from pre-trained and give like a model name here. I'm going to go with GPT-2 because, yeah, for testing purposes. And then you also can get the actual model, pre-trained model for GPT-2. And let's see what happens when we get like a text. Let's say the text that we had once upon a time, there was a, and let's see what happens when we call this tokenizer on this text. Let's see the output. So you see the output is a list or a tensor of IDs, which these IDs correspond to this input that we gave. So apparently the word once had this ID, the word upon had this ID. And if you pass this tokenized input to your model, and then you see the outputs, you see the outputs are also a set of IDs, which again are are the IDs of the words generated. So you need to decode them back into meaningful words. And for that, you can use, again, the tokenizer. And you will be able to see the actual meaningful generation of the model. This cell was there just to show you the pipeline is somehow abstracting away this piece of code. So, and this is what actually happens in the core of it when you use pipeline text generation with some model. It uses a tokenizer, tokenizes the input, and then generates the result.
But wait, just something, some people had questions. With Llama, if you can't use it and you receive an error, it's because you have to agree to the terms and conditions of the Llama model. Some people had this problem. So yeah, some people have this problem. So just go to the Hugging Face and you can fill a form for Meta to give you access. But for the sake of this workshop, we can just put GPT.
Yeah, I already asked for access, I guess, because it says that you're granted to have access to this model. And it finally
fill a form and with your affiliation. And
yeah, it takes some time. Then they'll send you some email. It's just for the agreeing to some legal terms. Yeah. But you can, of course, change like the model that we used here. You can also stick to GPT-2 just for testing purposes. All right, so we saw an example of text generation. There are also other types of tasks that you can do. By the way, I'm going to answer the questions for Hugging Face before moving on to the next part, but let's first explore different types of tasks. You can also use sentiment analysis. Sentiment analysis is the task of categorizing inputs and texts into two classes, positive or negative, based on their meaning. And you can do this using the models on Hugging Face. You can again define a model, and this time you set the task to be sentiment analysis. You can provide a model name, and you can also leave it empty, and it will set to a default model. So we're gonna just go with default model, and we're gonna provide it with a list of inputs. Let's say, I love this movie. I hate this movie, and we are also considering an example in French, which apparently translates to "this movie is terrible." Just correct me if I'm wrong.
Yes.
Okay, and let's see what the output would look like here for this model. So you see here, it says that no model was supplied, so it was defaulted to this model that you see here. You can of course go and check its description on Hugging Face. Just go, yeah, I think this is the model. You can read the description here. What is important here is that this model was trained on English data and English text. And let's inspect the outputs here. So you see for the first input, it says it's a positive sentence with this score. That's right. The second input is negative. That's also right. But for the third input, it was unable to classify it correctly because that the data that was used to train the model was in English text, not in French. So it doesn't have any idea about French text.
So in practice, you should use the correct models from Hugging Face. Always, Hugging Face has a filter for selecting languages and everything. So when you want to use the model there, make sure that
it's really important to don't make assumptions, but rather rely on the descriptions of the models. You can also do translation. We're going to just do this part maybe fast. Okay, and then you can, again, skip providing any model's name. It will default to some model, and you can translate like English text to French. So far, all of these models that we used are loaded onto your own device. So there are some computations used on your device. As you remember, I also explained about Hugging Face Hub and the services they provide in terms of API. You can use Hugging Face Hub to send API requests to get the generations instead of loading the models on your device. And for that, you need to first install the library. And of course, you need your API token in this part, especially. And we're gonna define a client. Oh, sorry. We're gonna first from Hugging Face Hub import the client, import the inference client. We're gonna define an inference client, and you can give the model name here. For this part, we are going to use a model that is actually supported by these inference providers. And I already talked about it, but there's an open source version of GPT that is supported for inference for API inference service. So I'm going to use this model here, OpenAI GPT OSS, which means open source.
By the way, OSS is a reasoning model.
Oh, reasoning model, yeah.
Model, just to get OSS is one of those reasoning models.
And it has 22 billion parameters. So you don't want to host this model on your device. Like it's gonna take about like 90 gigabytes of storage, I guess, at least.
Unless you have a very interesting device.
Yeah.
Not normally.
And yeah, and then you can use this interface and this API to say create a chat completion request, and then you can pass some messages to it. Let's say hello, how are you, or let's ask a more meaningful question like explain to me what an LLM is. And let's just capture the response here and just print it out to see the response. So now what happens is that it sends like an API request to some inference provider, and all of the computations are done on like a dedicated server. And as a response, you get a chat completion output object, which has some structure, and the actual content generated is somewhere here, actually. Like you have to first select the first choice, and then the message, and then the content of the message. It's just the structure of the object. But then you can just access the content, the generated content from this line of code, and then you see it says what is an LLM. It tries to, I think, explain it, right? Yeah, it's the type of artificial intelligence system that learns to understand. All right, so before we move on to the OpenAI, is there any questions for Hugging Face?
Yes. Hello?
Yeah. So the response that is returned is like a specific class. It's a specific object from a specific class. So you see it's an object from chat completion output. It's like an object that you have to access some part of it. It has some extra information here that necessarily you're not interested in all of it. And you can see this object has like, this object has a field called choices. You see, this is a chat completion output. It has a field called choices. It has, and then you can get the first choice. The first choice is another object of chat completion output complete class, which you can get the message of it, and then the message of it. Sorry, what? Yeah, sorry. Yeah, you have to get the content of it, and then you can get the message of it. So it's just about the structure of the object. You can just print out the response and see how it looks like.
So if I choose the choice number 1, I will get another.
I think in this case, only one choice is returned because you only provided one input, but there might be some cases that you provide a list of inputs and then you get a list of outputs.
Rule of thumb, how many parameters you would want to
Depends on your memory size.
Yeah.
Yeah, well, the average.
Like I think on a 16 gigabyte memory, I think you should forget more than 8 B. And even 8 B takes much of your. It's more like GPU memory actually. I don't know if you're Windows and Mac. So on Mac, memory is shared between GPU and CPU, but on Windows you should check the GPU memory in particular.
Okay, but it's in the billions.
Sorry?
It's in the billions, yeah.
Oh, yeah, it's in the billions. Like 8 B, I think is the farthest. So
Yeah,
more than
it's the
8
max.
not possible, I think. Yeah.
I personally have not used more than 3 billion on my laptop.
Locally, yeah.
Yeah, locally, yeah.
3B could work on many normal laptops that have.
Okay, so now we are going to move to our next API provider, next API service. It's OpenAI. I assume most of you have heard about OpenAI because of ChatGPT. It's pretty famous, but they also provide some APIs for you to send API requests to their text, chat, image, and audio models they have. You can either send REST API requests or you can use their library in Python called OpenAI. And the models here are mostly closed source, I guess, and they are high performance models, as you all know from ChatGPT 2. But for this, you need an API key and you need to provide your billing information on your OpenAI account. So let me just quickly go to, if you go to their documentations, you can see the list of models, for example, they have. Gold GPT models for text generation. They have Sora, the trend model nowadays. And yeah, you can choose from a different set of models. And in code, it looks like something like this. All you have to do is to install OpenAI library in Python, and then you can define a client. And then again, you can, using the same interface, create and define the model you want to use and define the input. And then a request will be sent to the GPT, to the OpenAI model, to the OpenAI model, and then the response will be sent back to you. For this, again, you'll need to provide your API keys. And the difference between OpenAI and Hugging Face is that I think Hugging Face provides you with some free quota, so you can probably use it for testing purposes, but OpenAI asks you to provide your billing information without any free quotas. So that's why you can't probably use it now unless you provide your billing information, because you are going to get charged per number of tokens you send. And for this reason and for the purpose that you can probably use, this is another. So after you get your token, you can start by installing OpenAI library by running this line. And then, as we saw some examples before, you can define a client, an OpenAI client. And this way you can select the model that you're interested in sending the request. And then you can provide your messages as the role of a user. And again, by accessing the first choice, the message, and then the content of that message, you'll be able to see the response of the model. It takes some time, but yeah, you see, it explains what an LLM is. But it's not only restricted to text generation. You can also generate images using their image generation models, such as DALL-E. For that, again, you can use this client that you define. You can use their images that generates endpoint, and you just provide the model name with some prompts. I mean, these are extra parameters you can, of course, ignore. And let's now run this command. And we ask it to generate a beautiful landscape with a river and mountains, for example. Oh, sorry.
Can you go back to the Excel?
Yeah. By the way, I'm going to share the code and the field out notebook later, so you don't have to worry about completing everything, because I used tools for generating some of the code. Anyway, for image generation, it takes some time and it gives me some image response. If you scroll right, there's like a URL with this image generated, and then you are able to see your image. Of course, you can also get this image in your code by sending some requests, some GET requests. But the purpose of this part was to show you that you can generate text, you can generate images, you can use basically all of the OpenAI's models. Here's also like a fun example. I think we can skip it, but you can definitely check it at home. I defined 2 LLM clients and I let them talk to each other and negotiate about the topic. I instructed one of them to be a believer in one topic and the other one to be a non-believer in that topic. And I asked them to just try to contradict the other one and try to negotiate with each other somehow about a specific topic. And then like, for example, about playing video games. Like one LLM tries to prove that playing video games is actually helpful. It's helpful for critical thinking and problem solving. The other one, the non-believer one, tries to contradict that and say, okay, then you can probably put some time on more productive activities. So this is just like an example of back and forth negotiation between 2 LLMs. And it was like a fun example to just let 2 models talk with each other. And I just see the output here. You can also try like more controversial topics. Okay, we probably can have a discussion about this just quickly. But LangChain is the next tool that we want to talk about. It's just a framework for building LLM-powered apps, which gives you some components that you can add to your LLM models, such as prompts, memories, tools that you can add, and using these you can define agents. We are not going too much into details about LangChain today. But just to give you an example, this is how it looks if you want to create an agent. You can again use a library in LangChain, a library in Python for LangChain, and you can add a tool. You can use a model for that, and you can create an agent using this model and tell it to use this tool when answering this question. And what it does is that when you ask this model a question about the weather, it tries to use this tool, which in this case simply just returns the weather in a simple, as like a simple method in Python. And this agent will use this information in the generation. Of course, you can add API tools so that some API request is sent to some weather API, I guess, website, which then responds back the weather and gives you the weather back. But the purpose is that you can create agents with different tools and different modular components you can add to the LLMs for that. But I'm just going to go over the first example. There's a concept called prompt template. You can define a template for like a general template that has a missing information and a missing parameter. And then let me just first define this prompt template. So I'm going to go with this prompt template. I say I have a template like this: generate a short marketing slogan for a company called something. And this name is the input variable that the user can later on resolve or invoke. And I'm also going to use a model for this purpose. Just note that LangChain has its own version of OpenAI and Hugging Face models. These are the models that are somehow a wrapper version that adapts to the LangChain environment and the LangChain ecosystem so that you can chain different components to each other. But I'm using a library called LangChain OpenAI, which has a wrapper version of OpenAI that we just saw before. But simply, again, you can just define the LLM here as OpenAI with GPT-4 model. And then you can define chains of components. That's where I guess LangChain is mostly useful for. You can define chain of basically components where you say first resolve this prompt, first first change this name parameter to the thing that I give here, let's say Lozak, and then send this output to this LLM, and the LLM will try to generate a short marketing slogan, for example, for Lozak. If we run this, I have to probably use, this is the template. Let's go with just the default model and let's see what happens there. Yeah, I mean, it was a strong. Okay. And you see, like, a slogan was generated. The prompt was replaced. This name part was replaced with Lozak, and then it generated like a short marketing slogan. We're not going to focus on LangChain further on. I would like to go to the mini project I would like to implement, but before that, I would like to ask you guys if you have any questions to just ask. I know it was a little bit like fast coding, but I'll provide the coding, like the filled out notebooks later on, so don't worry if you couldn't catch up. But I'll be happy to ask any questions now, to answer any questions now, sorry. Okay, so let's now jump into the mini project we have, just quickly.
We have time before the second batch of research that arrives.
Okay, so still have time. Okay. The actual mini project that today we want to work on is trying to implement a chatbot here for a website that we have. Let me just have for your website, for your app. And let's say you're interested in designing like a tool here that is able to answer users' questions. I think nowadays you see this widget in most of the websites when you go and try to explore them. But let's say our goal today is to design and implement this part for your website or your app. Just to give you a brief idea about the code base, we have two folders here, back end and front end. For the front end, we have some set of static pages, which are simply HTML pages. You don't have to worry about them. We have a JavaScript file, which is basically handling the interactive elements. All you have to know is that when the user submits like a message here, then a request will be sent to this to this endpoint, to localhost port 8000 and to chat endpoint. And our goal today is to implement a server that is running on this localhost 8000 port and accepts requests on chat endpoint and can process this chat response and chat input. So for that, we use a Python server, a Python fast API server. And I don't want to go into the details on how fast API works, but it's basically a library that allows you to design APIs and like run servers on some host and some port. All you have to know is that on the server, we have a running application that is running on some host, on some port, and is listening on some endpoints. The chat endpoint that we just described here, that is the address that the JavaScript file will send the message to. And we would like to implement this part. At this point, the request is received, the data is extracted, and then it's just returned back as a JSON element. So if we go to our web, if we first run this file, you see that it says the server is now running. I mean, it's a Ubicorn server running on localhost 8000. So now if I go to my website and let's say hello, all it does is that it returns back received data equals something. So it shows that it's connected because now I can see indeed that this is returned in the chatbot. So now in this part, we would like to actually return a meaningful message instead of just returning some template message.
Did everyone is fine here? Yes. Any questions? Fine?
Okay, so that's good. Yeah, sorry, I should have asked it. Yeah, for that, we can use just one of the tools we saw before. For example, we can go with the OpenAI library, and we can define a client here. And then later on here in this part, you first extract the message from this data, and then you get the response of this chat completion from, for example, GPT-4. And then you pass the response here. Let's say, yeah, this way. So now I expect everything to work. We can also provide some system prompts to it. So I'm going to define the system prompt to it, which basically instructs the model that you are a helpful assistant. Please try to answer the following questions in a meaningful way, for example. And then you can also add this system message here, system prompt here, sorry. So now if I reload this server, I expect it to be able to answer to questions and any questions. Okay, oh, that was because here I should use my own end file. I forgot about it, sorry, which you don't see on the project because it's hidden. But generally you should define because you're using your tokens from this .env file that you have updated. But let me just reload it again. And it's going to take some time, and it responds back to you with hello as an AI. I don't have feelings. Okay, I don't care. But there's a problem with this chatbot. It doesn't have any clue about our website's information. Let's say the user comes to this website and asks about like the contact number of the customer support. Tell me the contact number. Let's see what happens when we ask such a question here. Well, it says I can't assist with that because it doesn't have any information about our website, our information that we want the chatbot to know about. And that's where we use the method that Marcia described, RAG, Retrieval Augmented Generation. And we somehow feed the information we have on the website to this chatbot so that it understands about the information of the website and it can answer questions based on those information. For that, I just have to simply add 3 lines of code. And I'm going to use a tool for extracting this information and for storing these embeddings in a vector database efficiently in Python. There is a library for it called llama index different types of tools that you can use. Llama index, yeah. I'm going to use the simple directory reader and a vector store index. And this is just a tool that has the data structures for extracting the data and also storing the embeddings in a vector database, enabling you to efficiently retrieve the relevant part of the information. So what I do first is that I get a list of documents by saying, by using this simple directory reader, I just use the information we have for static pages. So you see we have some HTML pages. They have some information here inside the div tags. And it might be hard and it might not make sense to include all of these markdown information as the context. But thankfully, because of this simple directory reader, we can extract the relevant information out of this. And we can just provide the address of the data that we have, the data directory that we have. In this case, we say front-end static pages. And this line just gets all the documents from that folder and get the meaningful and extract the meaningful information from those. We would like to build an index, which basically just embeds, first of all, it splits the documents into chunks of information and then encodes them into an embedding and stores them into a vector database so that later on you can retrieve the relevant part of the documents. And there is a component there for retrieving the most relevant piece of documentation, which is the retriever here. And having this retriever here, all you have to do is come here and then say context equals retriever dot, like for example, invoke, or I think it's retrieve. Yeah, it's retrieve. And what this does is that it tries to embed this message as like an embedding, and then goes and find the most relevant pieces of chunk of information stored in our vector database and returns back the most similar part of the information that we had on those HTML pages. So let's also print this context for the sake of understanding what this is exactly. But I'm also going to use this context because remember, we wanted to extract this context so that we can add it to the message we give to the model so that it knows about this data. So I'm gonna here add the context here. I'm gonna say the context is equal to, like the context is this, and then the user's question is this message. And also I'm gonna modify the system prompt. I'm gonna now say you are only allowed to answer these questions about using the context provided to you. And maybe you can also say, in case you are not sure about the answer, just reply back by saying, for example, I don't know. We don't want the model to hallucinate. We don't want it to answer general questions. Like if a user asks what is an API, we don't want the chatbot to be able to answer it. We just want the chatbot to be personalized to our website. And finally, having this, we expect this to be working. So if we now reload the server, now if we go to our website, let's ask a question about what is this company. Okay, it's still not using the context for some reason, but let me see. Oh, let's see the context here. Oh, I should save this file before running. Such a cursor faulty implementation. Okay, let's just reload the server. That's good that I actually printed the context because then I could see it's not actually using the context. What is this company about? Okay, so we have Let's see.
Context and array.
Okay, so we're gonna just get the first. But you see here, the relevant part of the HTML is somehow printed here. Like the relevant part of the document is extracted as the context, and we see, like for example, I mean, this is not really making sense here, but like here you can see, you can see the name of the company here at least, right? So it shows that actually the relevant context is retrieved. Let me just correct this.
STR of the context. I think should work.
Okay. And you also notice it takes some time because it tries to build these indexes on your own device. And so that's why it takes some time. This time, if you try it, okay, nice. And it is able to actually answer your question, and it's able to provide the name of the company and provide some extra information. You can also ask about the products they provide, and then you can also test that if you want later on. But what products do you provide? I was taking too long, but okay, that's strange. Yeah, so it shows you the products that this website has. I mean, you can indeed limit the number of tokens generated, but yeah, this is basically the chatbot that you would like to integrate into your apps, to your website, just for the sake of being more user-friendly. I think I can answer some questions now before I go over the last two slides. And yeah.
How could we make it faster and modify precisely formats to adapt to? Is that possible?
Yeah, so for making it faster, you can probably use like a more lightweight model, for example, or you can probably give it less context. So probably only add the most relevant context instead of, because previously we added the most relevant context. There are some scenarios where you can add the top 3 most relevant nodes, or the top 3 most relevant parts of the documents. You can indeed limit the context, but in terms of making it faster, I think it really depends on the model and the resources that you have. I don't know any other ways to make it faster, maybe.
And of course, for the certain output, there are a lot of ways. You can use structured outputs, return out in a structured way, or just use a few short examples so that it knows the.
Before I end this part, I would like to just point out that we had some coding implementation for this, but there are indeed nowadays some tools that you can literally design such a server using some automation workflows. And actually, I was surprised to know about this tool called N8N. I decided to give it a try last week, and I spent 30 minutes on it and was able to basically implement the same thing we have here on the code on the left-hand side on N8N by designing a fully functional workflow that listens for requests and is able to give this request to Google Gemini chat model, and then the response will be sent back. So the point is that nowadays you don't even need to be able to code. You just have to understand the concepts, and even, who knows, maybe someday you can just use these tools as working servers, and you don't even need to code anymore. So it's important to know about the concepts rather than the syntax and the methods names. And yeah, with that, I think we can move on to quiz that Parsa has for you guys.
So any questions?
And yeah, in case you don't have any questions, we can.
Is our fine until now pretty clear?